Hi, this is Haisha Wang, and today we are going to talk about the maze 2. And let's see the prompt. The input are maze, which is a grade, and also the start index of the bow, and the destinations. And the rule is that we should move the bow from the start and to the destinations, and we should return the minimum path along this moving process. And during the moving process, we should follow some rules. As the rule is that if we try to move the ball and we choose the directions, we cannot stop the moving until the ball hits the wall. And for example, the ball is here, and we choose to move left, and it will go to these positions until the ball hit this wall, and then it will stop. Yeah, and actually there are two kinds of the walls. The one wall is the boundary of the maze, and the second wall is represented as one in the maze, like this one. Um, Usually I will use the DQ to solve this kind of problems, but there's something tricky in this problems. Let's show. Uh, let's just suppose there are two kind of the candidates of the positions that we can pop from the from the EQ. And so we just suppose there's no wall here. And there are two kind of the ways. So the first way is that, and the second way is like that. So because we are supposed to return the minimum of the path. So actually, these two candidates should have different weights, and actually we should prioritize on this node to be first pop from the DQ. So it's really similar to it's intuitive to just replace the DQ here with the heap because every time we just pop out from the heap with with the positions that are is closest to the star index, and that will make sense. And so that's pretty much about the logic behind that, and also the tricky things in this process. So let's try to code it out. Let's get the shape of the maze and also the heaps. And the we should also use hash map to store um, which index is already visited or not, and to store its uh, some informations. Just initialize the star index with zero distance. And here we just uh, in the heap we should store three informations. One is the distance from the start index, and the second one is x positions, and third one is y positions. And we I used to use the two arrays to denote four directions of the movement. Yeah, actually this means that move right, and the second pair is means to move down. Yeah. Well, sorry. Well, so he is not empty of the closest positions that from the starting index and added to our and just choose the directions, and then we um should follow the rules. So if the ball do not hit the wall, it will not stop. This is to check whether it's walls that represent to 1. So if it's equal 0, we should continue to move the ball. Actually, we should here use a step to denote how many steps we move the ball during this process, and every time just updated by +1. And after we uh, hit the wall, we just break up the while loop, and we just check if the y is just equal to the destination, so also um we can just return the step plus the distance. And if the xy not being visited, so we should append to our heap. Actually, there are the second case that we should append to our heap, which is if the visited represents the step as this. This is mean that we find more closer paths that reach the positions at x y. So we should update it the hash map to be the minimum of these two, because we want to the minimum of the pass minimum pass, and just copy this line. I think this is pretty much about. And then we just, if not, we can do the -1. I check whether it works or not. It seems to work. Yeah, let's go. Yeah. That's pretty much about this problem. Thanks for watching.